Hello everyone, this is Amika Mahajan. Welcome to my channel. Today we will study behavior of bar magnet in a uniform external magnetic field. We consider a permanent dipole. That means we talk about bar magnet having dipole moment capital N in a uniform external field B like this at an angle theta with respect to this field B. Now, force will act on north and south pole. Force acting on north pole will be plus mb. What is the meaning of plus mb? In the direction of magnetic field. But force on south pole will be opposite to magnetic field. So it will be negative sign here. So what we find? Net force F1 plus F2 will be 0. But both forces are having different point of action. As a result of which they will constitute a couple. And torque will act on the dipole. So, what is couple? To equal unlike parallel forces having different point of action. So, forces minus mb and plus mb. These are equal in magnitude but unlike parallel forces. And they are having different point of action. So, they are forming a couple. Now, we will find torque. What is torque? Either force into perpendicular distance. Here, it is also known as moment of force. So what is either force? It is mb in magnitude. And what is perpendicular distance? For that, we draw NO and SO perpendicular to each other. Now, which line will be perpendicular? ON will be perpendicular. Perpendicular to this force mb and perpendicular to this force produced backward. So, perpendicular distance will be ON. Now, to find ON, I will take this right angle triangle. This right angle triangle, what is sine theta? Perpendicular upon hypotenuse. What is perpendicular? NO, which I have to find out. And hypotenuse SN, distance between two poles, it will be 2a, dipole length. So what will be NO? 2a into sine theta. So when I put force and perpendicular distance, it comes out to be mb into 2a sine theta. We know that m into 2a is magnetic dipole moment. So it will be capital M. So what is left? mb sine theta. This is the magnitude of torque. When I express it in vector, it will be m cross v. Sine theta will be removed and cross product will be there. Now, what we find? That torque acting on bar magnet when it is placed in magnetic field at some angle theta. It will be m cross b. This torque will act to align the dipole in the direction of field. When this dipole or bar magnet is aligned parallel to field, then what will happen? Torque will be 0. When torque is 0, then dipole is in equilibrium. So what is magnitude of torque? mb sine theta. We know that m is not equal to 0, b is not equal to 0. So sine theta will be 0 to have torque equal to 0. Or theta will be either 0 degree or 180 degree. That means bar magnet, dipole moment should be parallel to field or dipole moment should be anti-parallel to field. Then only dipole will be in equilibrium. When we have to rotate the dipole through some angle theta, let it is d theta. Then work will be done. Work will be torque into d theta. Put the value of torque, it will be mb sine theta. So integration to calculate the work when we rotate it from angle theta 1 to theta 2. We know that integration of sine theta with respect to theta will be minus cos theta. So when I put limits, upper limit will be put first. Negative sign I take outside, it will be cos theta 2 minus cos theta 1. When I adjust negative sign, it will be mb cos theta 1 minus cos theta 2. So this will be the work, and this work is stored in the form of potential energy. So potential energy will be mb cos theta 1 minus cos theta 2. Now I will take very special case when dipole is initially held at 90 degrees. So theta 1 is 90 degree and it has to be rotated through some angle theta. So theta 2 is 0 degree. When I put value of cos theta 1 and cos theta 2 here, theta 1 is 90, theta 2 is some angle theta, then what will happen? Cos 90 is 0. So what is left? MB into minus cos theta. Or you can say minus MB cos theta. Now when I put theta equal to 0 here, what will happen? This work or potential energy will be minimum because cos 0 is 1. So minimum potential energy will be minus MB. When potential energy is minimum, then stable equilibrium is there. Stable equilibrium means dipole moment and field should be parallel to each other at angle 0 degree. But when I put theta equal to 180 degree, then U will be plus. It will be plus MB, maximum value of energy. Because cos theta is minus 1. Minus 1 will be positive. Now, because energy is maximum, so dipole is in unstable equilibrium. What is meaning of unstable equilibrium? That I have to place dipole, or you can say bar magnet in field in such a way that magnetic dipole moment and field are opposite to each other, so that angle is 180 degree. Thanks for watching this video. Like, share, subscribe my channel.